Hi everyone, it's Math with AUB. Let's get along with another frame based on first year MCQs, courtesy of Aga Khan Board as well as NED past papers. Past papers, 100% past papers. I can show you proof. These are the questions from different books, but my selection is humongous, in my opinion. Let's see and find out. Our question number 1 reads as, if fourth roots of the unity, in the fourth roots of unity, what are four roots of unity? 1 minus 1 iota minus iota. These are four roots of unity. Four roots of unity. Unity means 1. Okay, cool. 1 minus 1 iota minus iota. This is a group under multiplication as well as division. That is not the question in that case. It is given us the product of the real roots. Product of real roots and product of imaginary roots or complex. Product of real roots is denoted by m and product of imaginary roots is denoted by n. We are asked to find their difference, m minus n. Product of real roots. What are real roots? 1 times minus 1. Result is minus 1. So m is equal to minus 1. The product of real roots. M is the product of the real roots. It's mentioned. It is directed towards imaginary roots. Product of imaginary roots. Imaginary roots are iota and minus iota. Their product iota times minus iota square. Value of iota square is minus 1 minus plus 1. That's value of n. That's value of n. That's value of n. We are asked to find what is the difference of m minus n. M minus n. M is minus 1. N is 1. So minus 2 is our answer in that case. Minus 2 is our answer in that case. In fourth roots of unity, these are the fourth roots of unity. 1 minus 1 iota minus iota. 1 minus fourth roots of unity. The product of real roots is m. Real roots is m. 1 into minus 1, that is value of m. Product of real roots is m, and the product of imaginary roots, or one can say complex conjugate of each other, is n. Then the value of m minus n. We have sorted it out. Okay. Moving to second question based on complex quadratic equation. At present, if alpha and beta are the roots of equation, ax square minus bx is equal to 1. Ax square minus bx is equal to 1. The value of alpha minus beta square, negative alpha plus beta square is what? So we have equation ax square minus bx is equal to 1. Writing in standard form. Standard form means is equal to 0. The standard form, we have ax square minus bx minus 1 is equal to 0. Okay, we are asked to find the value of alpha minus beta whole square minus alpha plus beta whole square. It's a really simple identity. Open it up. It's alpha square minus 2 alpha beta plus beta square. There is minus symbol. Now open this up. It will become alpha square 2 times alpha beta plus beta square. Cool. Open up, multiply minus throughout. We have alpha square minus 2 alpha beta plus beta square minus alpha square minus 2 alpha beta minus beta square. Look at this, cancelled out. Minus 2 alpha beta minus 2 alpha beta. It is equal to minus 4 alpha beta. We are formula alpha times beta. It is product of roots. Product of roots is given by 4. It is minus 4 is mentioned, c over a. Product of the roots is equal to c over a. So value of a is a in that case. Value of b is equal to minus b, and value of c is minus 1. So put here c is minus 1, a is a. Negative 4, value of c is minus 1 over a. Minus plus 4 over A. 4 over A or 4 times 1 over A. Option number D is a right option in that case. Option number D is the right option in that case. That's quadratic equation. We are familiar. The sum of quadratic equation is given by alpha plus beta is equal to minus B over A. Product of the roots is given by C over A. And the formation of quadratic equation is x square negative times sum times x plus product. Plus product. Some literature writes as instead of sum they mention alpha plus beta, instead of product alpha times beta. Okay, cool. Moving towards question number 3. The positive square root of 4 times 1 plus 1 over 10 square beta. The positive square root. The positive square root of 4 times bracket 1 plus 1 over 10 square beta. 10 square beta will be equal to what? Positive square root. Positive square root of what? 4 times 1 plus 1 over 10 square beta. There are 2 to 3 methods to solve this. Just 1 over 10 square beta is equal to what? 4 times 1 plus 1. Reciprocal of 10 is cot. Reciprocal of 10 is cot. Is equal to 1 plus cot square beta. From simple identity, 1 plus cot square beta is equal to cosec square beta. Cosec square beta. Cosec square beta. We are asked to find its positive square root. Positive square root. Root 4 times cosec CSC square beta. So we have plus square root of 4 2. Square root of cosec square is cosec beta. Cosec beta. That's our required. 2 times cosec beta. 2 times cosec beta. 2 times cosec beta. Or one can take LCM. One can take LCM 4 times. It will become 10 square beta plus 1 over 10 square beta. We are familiar. 10 square beta is 1 plus 10 square is equal to sec square. We have sec square beta over 10 square beta. Cool. 4. Sec square is equal to 1 over cos square beta. That is value of sec divided by 10 square means sin square beta over cos square beta. Make it reciprocal. 4 times 1 over cos square beta times cos square beta over sin square beta. Cancelled out. 1 over sin square is equal to 1 over sin square is equal to sec square. 1 over sin square is equal to cosec square. So same is the result for cosec square beta. Taking square root, positive square root, it's 2 cosec beta. 2 cosec beta. The same answer. The same answer. Either to tread this path or this. Reciprocal of 10 is cot. 1 plus cot square is equal to cosec square. Taking positive square root, that's our required answer. I have already taken it. Okay. Question number 4 from GP, geometric progression. If in a GP, if third term is 904, third term is 904, and sixth term is 243 over 32, and sixth term is 243 over 32, then find the first term and the common ratio. First term and the common ratio. Really very easy one. T3, that's our 9 over 4, and T6, we have 243 over 32. Okay, 9 over 5. 9 over 4 can be written as 3 over 2 square. And what about this T6? T6, these are the simple powers, the mere powers of 243. Factorize this up. 381, again 327, again 3, 210, 3, 4, 5 times. So 3 power 5 over, it must be the same. 2 times 5, 16, 8, 4, 2 and 2. 2 power 5. 2 power 5. So 6 term can be written as 3 over 2, 5. From this, we can easily judge our R is 3 over 2. Our ratio is 3 over 2. How to get along? If I mention first term 1, second term multiply by ratio 3 upon 2, then third term is 3 upon 2 square as it is mentioned. That's our AR, that's our A square. Similarly, 1 times more, it will become 3 over 2 whole cube, 3 over 3 whole power, 3 over 2 whole power 4, 3 over 2 whole power 5. That's our first term, second term, third term, fourth term, fifth term, sixth term. Easy to verify without applying any formula. Without applying any formula. Keep 2 to 3 things in mind. In case of geometric progression, each thing is power of 2, 3, 5, or combination of any 2. Maybe 3, 2, might be 3, 5 or 2, 5. Geometric progression is based on the product of 2, 3 and 5 or any of the ratio of 2, 3, 3, 5 or 2, 5. It's okay. Or one can sort it out by orthodox method by applying formula, term formula, what is A, what is R, and so on. Let me adopt that strategy as well, utilizing formula to get at the result. Mostly I solve the question by normally dividing and multiplying in case of GP without wasting time. Okay, third term is same question. When you have another strategy, 9 over 4. Third term means AR 3 minus 1, that's our 9 over 4. Means AR square is going to be 9 over 4, that's our equation number 1. From third term, from the sixth term, that's our 243 over 32, if I'm not at fault. Okay, sixth term, put AR 6 minus 1, that's 243 over 32. Means we have AR 5 is equal to 43 over 32. Cool. Divide the smaller quantity with the greater quantity. AR 5 divided by AR square. Similarly, 243 divided by 30. 243 over 32 divided by AR square means 9 over 4. Divide the larger quantity with the smaller quantity. Divide the larger quantity with the smaller quantity. We have R cube here. Simplify this, 243 over 32, 4 over 9. 4 times 8 for the 32, 927 the 243. Just 4 times 8 is 32. We have R cube 27 over 8. From this we can easily manage the value of R, that is 3 cube over 2 cube, means R is equal to 3 over 2. R is equal to 3 over 2. R is equal to 3 over 2. Put in the tiny equation, in the smaller one, that is A times R square. A times R square is equal to 9 over 4. Instead of R, put 3 over 2. We have A times 9 over 4 is equal to 9 over 4. Solve for A. 9 over 4 times 4 over 9. Cancelled out. We have A is equal to 1. A is equal to 1 and R is equal to 3 upon 2 by orthodox method. So option is B in that case. Okay, moving to the fifth question. When the conjugate of a complex number P, is expressed as negative times iota plus C iota square, then find the value of P. What we have given, when the conjugate of a complex number P, there is a complex number P, its conjugate is expressed as minus iota C iota square, then what is the value of P? When the conjugate of a complex number P is denoted by this one, minus iota plus C iota square is conjugate of P. I have mentioned P conjugate is equal to minus C iota square. Iota square is equal to what? We are familiar. Minus iota square is equal to minus 1. Iota square is equal to minus 1. It will become minus iota minus C. That is the value of P conjugate. That's the value of P conjugate. We are interested in P. We are interested in P. We are familiar. P conjugate again conjugate is equal to P. P conjugate again conjugate is equal to P. P conjugate again conjugate is equal to P. In case of conjugate, we have to change the symbol of imaginary part. We have to change the symbol of imaginary part. We have to change the symbol of imaginary part, not the middle one, not the middle one, not the middle one. Change the symbol of imaginary part. Change the symbol of imaginary part. Taking conjugate both sides, minus iota minus c, conjugate. It will become P. Changing the symbol of imaginary part. Iota minus c is the value of P. Iota minus c is the value of P. Iota minus c. So option number C is the right option in that case. Next question. The imaginary part of V, where V is iota over A raised minus 1. The image, another number from our question from our board based on complex numbers. Based on complex numbers. Good one, baffling one, the perplexing one, but easy one as well. V is equal iota over A raised minus 1. Raised minus 1. We are asked to find its imaginary part. Imaginary part. Okay. How to turn the exponent positive? How to turn the exponent positive? Make the base reciprocal. Take the reciprocal of the base. It will become A over iota raised positive. Raised positive. How to turn negative exponent into positive? Make the base reciprocal. Take the reciprocal of the base. Take the reciprocal of the base. Okay. Cool. A over iota. Now simply rationalize. Rationalize. Divide and multiply minus iota. It will become minus A times iota. Minus iota times minus iota square. And iota square is equal to minus 1. Mention here minus A iota over minus times minus 1. Minus plus 1. Minus A iota. Minus A iota. So the imaginary part is going to be, imaginary part of V is minus A. Imaginary part is minus A. Imaginary part is minus A. Imaginary part of this number is minus A. Okay, cool. Moving towards second last question of the frame, seventh, a good one, an elegant question. If A and B are the matrices of the order M into N and B is N into P, then what is the order of the product AB? What is the order of the product AB? If we have two matrices A and B, order of A is M times N and order of B is N times P. Then what is the order of A, B? A times B, A times B. Okay, we are familiar. If the number of columns of first is equal to number of rows of second, if number of columns of first is equal to number of rows of second, then they are conformable for multiplication. Then they are agreeable to multiplication. Then they are valid for multiplication. Number of columns of first matrix is equal to number of rows of second matrix. Number of columns of first matrix is equal to number of rows of second matrix. Then we are in a position to multiply the matrices. They are conformable for multiplication. Multiplication is possible in that case. Number of columns of first is equal to number of rows of second. Number of columns of first is equal to number of rows of second. Then after the multiplication of A, B, they are going to have the order M times P. M times P. It will must be slashed out. M times P. Then in the product of A and B, there are M rows and P columns. M rows and P columns. M rows and P columns. What the condition for two matrices to be multiplied? Number of columns of first is equal to number of rows of second. Number of columns of first is equal to number of rows of second. Then we are in a position to multiply the matrix. What is the upcoming order of the multiplication of AB? What is the order of the multiplication A into B? We can guess even without multiplication. That is, slash out the common portion. M rows and P columns is the order of A times B matrices. Moving towards last question, that is also based on complex numbers. We are familiar. When two complex numbers are equal, then the real part is equal to real part and imaginary part is equal to imaginary part. It's given to us if the given part 3x plus y minus 2 iota is equal to 5 minus 2x, plus 3y minus 8, 3y minus 8 times iota. Look at this one. If it is given to us, equality lies here. Real part is equal to real part, imaginary part is equal to imaginary part. On comparing, r is equal to r and imaginary portion is equal to imaginary. We have 3x is equal to 5 minus 2x. Solve for x, shift minus 2x here. It will become 3x plus 2x is equal to 5. 5x is equal to 5. So eventually x is equal to 1. What from the imaginary? Y minus 2 is equal to 3y minus 8. Solve for y. Y minus 3y is equal to minus 8 plus 2. Minus 2y is equal to minus, it's minus 8, sorry. Minus 8 plus 2, minus 8 plus 2, it is minus 6. Solve for y, y is equal to 3. So we have on ordered page xy is equal to 1 comma 3, 1 comma 3. That's value of x, that's value of y. Equality sign prevails. A real part is equal to real part, imaginary part is equal to imaginary part. Just compare them. We arrive at the result x is equal to 1, y is equal to 3. Option number A, option number A. Or sometimes it is given to us. It is asked 3, 5 is equal to 5, 3. No. Abscissa is equal to abscissa, ordinate is equal to ordinate, that is the case. If it is a small bracket, small parenthesis, they are not equal. 3, 5 doesn't equal to 5, 3. Because in that case, x is 3, x is 5. In that case, y is 5, y is 3. Abscissa is x, here abscissa is 5. Here ordinate is 5, here ordinate is 3. They are not equal. On the other hand, if there is a curly bracket, 3, 5 and 5, 3, normal sets, then they are equal, then they are equal, then they are equal. In that case, they are not equal, in that case, they are equal. Okay, so guys, it's my tiny effort for you to do something for you, to make mathematics looks simple enough, easy enough to comprehend. It's all by itself. Next.